If you are an electronics guy and preparing for interviews, then this video is for you. In this video, you will get a variety of questions based on flip-flops, gates, multiplexers, clock generation, Verilog codes, setup and hold time, synchronous versus asynchronous reset, RAM versus FIFO, and much more questions. So watch the full video and be ready with a strong concept of VLSI for your upcoming interviews. Starting with the first question. Your first question is design a NAND gate using 2x1 multiplexer. It's a very simple question. Let's see how we can do this. So this is a truth table of NAND gate. You can see here two inputs A and B we are taking, and this is the output. So 0, 0, 0, 1, 1, 0 and 1, 1, 4 sets we have, and accordingly we are getting the output 1, 1, 1 and 0. If we want to implement this by using 2x1 multiplexer, so that time what you can do, just take one input signal as a select line of that multiplexer. Here we are considering this A as a select line. So select line has two conditions, either it will be 0 or 1. So in case of 0, the output will be 1. It is not depending on this B. However, in case of 1, the output will be 0, 1, 1, 0. That means it is a negation of B. So what you can take here, it is a 2x1 multiplexer. A is given as a select line. Whenever this A is 0, the input should be 1 so that it will be given to this output. Whenever this A is 1, the B bar should be given to this multiplexer in order to get the negation of the values in the output. So this is how you can implement a NAND gate using 2x1 multiplexer. Actually, you can implement any gate by using this method. AND or NAND NOR, any gate you can implement, the method will be same only. So your next task will be just implement NOR gate by using 2x1 multiplexer. And let me know in the comment box how many of you have just completed that question. So coming to the next question, write a Verilog code to swap two numbers using non-blocking assignment. So here is the code. Whenever it comes to non-blocking assignment, we can directly swap the values. Suppose we have two variables A and B. So in case of non-blocking assignment, directly we are assigning the value of B to A and A to B. But here in this question, if it is asked to swap the two numbers using blocking assignment, then what changes will be there? This is the code. In that condition, you need to take a temporary register, and in temporary register you need to store the value just to avoid any kind of data loss. So here what we are doing, we are just storing this B register value to this temporary register and then transferring the value of A to B and then this temporary register value to A. So in this way you can swap the two numbers using blocking assignment. This is the example of blocking assignment and this is the example of non-blocking assignment. So I hope it is clear to you. Next question is write a Verilog code for clock generation. So if you are a coding guy, then this question is very easy for you because whenever it comes to a sequential part, you need to write the test bench for this clock generation and it is very simple. Here we have this module and this file name, then reg type clock. Initially we are assigning this 0 value to the clock, then in always after some time unit delay we are assigning this 1 value to the clock and then again after the same time unit delay we are assigning this 0 value to the clock. So what is actually happening here, initially your clock was 0, then your clock is made to 1 after some time unit and then again it is coming to 0. So in this way a clock signal will be generated. Since it is in this always block, that means it will be generated again and again. And this function will be finished after 100 time units. So here is your clock signal. This is how your clock signal will be generated. Here the time unit is nanosecond. So the time period of your clock signal will be 10 nanosecond. You can see here 5 and 5. So total 10 nanosecond will be time period of your clock signal. So this is a very simple code and you can write by your own. In case of any doubt, let me know in the comment box. Also, you can join our community VLSI point on the Telegram. There also you can discuss these small doubts with your peers. More than 700 students are there who are just connected with the multiple electronic students and discussing their doubts. So join that community, guys. It will be very much helpful for you. Next question is, what would be the input of JK flip-flop if a divide by 2 circuit is implemented using it? So what is the question here? You have a JK flip-flop and you have to convert it to a divide by 2 circuit. For that purpose, what input you need to apply in that JK flip-flop? So first of all, understand what is the meaning of the divide by 2 circuit. Suppose this clock we are giving here, and divide by 2 circuit means frequency will be half. So you can see the another generated signal, which is the output circuit. Here the output frequency is f by 2. This is the signal with f frequency and this is the signal with frequency f by 2. Obviously, if frequency is half, that means the time period will be doubled, because time period is nothing but 1 by frequency. So how you can implement that circuit? This is your JK flip-flop. J and K input is given, clock signal is given, and your output Q is there, and this is the Q bar. So in order to implement this divide by 2 circuit, simply what you have to do, just connect this J with Q bar and this K with Q. So what will happen in that condition? Just see this. Initially, just consider that your circuit is in reset condition. That time your output Q will be 0. If Q is 0, then Q bar will be 1. Based on that, you can allot the value to this J and K input. If Q is 0, that means the K is 0. If Q bar is 1, that means this J is 1. Now, in next state, if the previous state was 1 and 0, obviously the output will be 1. If Q is 1, the Q bar will be 0. Based on that, again you can assign the value to J and K. If J is 0 and K is 1, then obviously the output will be 0 only. If Q is 0, then Q bar is 1. Based on that, again you can assign the values to J and K. If J is 1 and K is 0, then output will be 1. Q is 1, that means Q bar is 0. Again, based on this value, you can assign the value to J and K. So one thing you can notice here, we are getting the same value after 2 clocks, 0, 1, then again 0, 1, then again 0, 1. So what is happening here, the clock which we had applied and the output which we are getting, there is a difference between 2 clock cycles. So this is how your divide by 2 circuit has implemented. Simply what you have to do, just connect this J with Q bar and K with Q, and you will get the divide by 2 circuit. Effectively, it will divide the frequency by 2. So this is how you can solve this type of questions. Coming to the next question, what is the setup and hold time? This is a very important question of STA, and these STA questions will definitely ask in your interviews. So setup time and hold times are the timing constraints in digital circuits that are important for ensuring the correct operation of synchronous sequential circuit, such as flip-flops, registers, and other memory elements. The setup time refers to the minimum amount of time that the signal must be stable and valid before the clock signal arrives. The hold time refers to the minimum amount of time that the data signal must be stable and valid after the clock signals arrive. You can see here in this figure, this is the time where the clock is coming. This is the time before the clock signal when the input signal should be stable. This time is called the setup time, and this is the time after the clock arrival. This is called the hold time. Here also the input should be stable. So this is the total time where there should not be any change in our input signal. This is called the setup and hold time. If the setup and hold times are not met, the flip-flops or the registers may sample the input data incorrectly and resulting in unpredictable behavior and potentially causing errors in the circuit. Therefore, it is important to ensure that the setup and hold times are properly designed and verified in digital circuits. This is the actual meaning of setup and hold time. I hope it is clear to you. Coming to the next question. Design a full adder using 4x1 multiplexer. A table for the full adder, we have 3 inputs A, B, C and 2 outputs sum and carry. 3 inputs you can consider from 0, 0, 0 to 1, 1, 1. Based on that you will get the output sum and carry. First of all, consider this B and C inputs as a select lines and then implement these 2 functions. So suppose B and C are the two select lines, then there could be four possible combinations: 0, 0, 0, 1, 1, 0 and 1, 1. Here you can see 0, 0, but we have two times: 0, 0, 0, 0, then 0, 1, 0, 1, then 1, 0, 1, 0, and finally 1, 1, 1, 1. Now see what input we are giving and what output we are getting. In case of 0, 0, A is 0 and output is also 0. Here A is 1 and output is 1. That means we are giving input A. Similarly, in case of 0, 1, this is 0, this is 1. In case of 0, 1, this is 1, this is 0. That means we are getting negation of A. In third condition, 1, 0, 1, 0, we are getting 0, 1, 1, 0. That means negation of A. And the final value of select lines are 1, 1. In case of 1, 1s, A is 0, output is 0. A is 1, output is 1. That means the input should be A. So this is the final implementation of the circuit. How you can implement the sum function by using 4x1 multiplexers. These two are select lines. We are considering it as B and C. And the input which you can take here is A bar, and A, as we have discussed by using the table. So this is how you can implement the sum function. In the same way, you can implement the carry functions too. And that you should do by yourself. If you have any doubt, let me know in the comment box. But it is very easy and I am very much clear that you can solve by your own. Coming to the next question, what happens if we don't write any default statement in Verilog? So in Verilog, the case statement is used to implement multi-way branching based on the value of a variable or expressions. The case statement allows you to specify a series of cases, each with a different value, and the code to execute if the value matches the case. The condition is, if you don't write a default statement in a case statement, then when a value of the variable or expression doesn't match any of the cases, the code will simply continue executing the next sequential statement in the program. That means it will not enter into the case statement because it is not matching with any of given condition. So the execution will exit the case block without doing anything. This is the reason why we should give a default value, so that if it will not match to any condition, you will get the output given in the default statement. This is the meaning here. Well, going to the next question. If you are finding this video useful, do subscribe it, guys. It gives me a motivation to make more useful videos for you. So don't forget to subscribe. फटाफट से आप सभी subscribe कर लो. Coming to the next question. If A is 1, assign Y equals to A. So here in this question, assign statement is given. And what is the meaning of the statement? Assign Y equals to. Now what is the meaning? If A is equal to 2 tick B 1 1, then a true value will be assigned to Y, otherwise a false value will be assigned to Y. But here the A value is 1. In binary, 1 is nothing but 2 tick B 0 1. So this A is not equal to 2 tick B 1 1. That means a low value will be assigned to Y. So Y is nothing but logic 0. This is the final answer. Next question is, how many flip-flops are required to implement mod 20 counters? 2 flip-flops can count from 0 to 3. 3 flip-flops can count from 0 to 7. Similarly, 4 flip-flops can count from 0 to 15, and in case of 5 flip-flops, it will be count from 0 to 32. But what we want a mod 20 counter, which is in between of 15 to 32. So to implement that, obviously we need 5 flip-flops. Because in case of 4 flip-flops, it will count till 15 only, and we want till 20. So 5 flip-flops are required. But one problem is there, it will count till 32. So what you have to do? You have to give some reset and clear signals by using NAND gate, so that it will count from 0 to 20, and then again it will just start from 0 and count till 20. So this is how you can implement a mod 20 counter by using 5 flip-flops. Start from 0 and count till 20. So this is how you can implement a mod 20 counter by using 5 flip-flops. Next question is, write a Verilog code for asynchronous reset. There are two types of reset signals, asynchronous and synchronous. So this is the code how you can write the synchronous reset. We will see the difference also between the asynchronous reset and synchronous reset in the next question, but here we are seeing the code, how you can write a Verilog code for asynchronous reset. Simply you should write module, then the file name, your module name, all the input output signals, then always at pause edge clock or neg edge reset n. Wherever you see this line, that means it is an asynchronous reset. Then if negation of reset n, that time 0 is assigned to Q, else D is assigned to Q end module. So this is how you can write a Verilog code for asynchronous reset signal. Now it's a time to discuss what is the difference between asynchronous reset and synchronous reset. There is a difference based on the timing and the design complexity. Based on timing, synchronous reset uses a reset signal that is synchronized to a clock signal of the circuit. The reset signal is asserted and deasserted on a specific edge of the clock signal, typically the rising edge or the falling edge. This ensures that the reset signal is applied to all the elements of the circuit at the same time, which helps avoid any timing issues that could cause glitches or other problems. However, asynchronous reset, on the other hand, does not use a synchronized reset signal. Instead, the reset signal is applied directly to the reset input of each element to the circuit. This can cause the timing issues because the reset signal may arrive at different times for the different elements, leading to the glitches or other problems. So this is the major difference between the synchronous and asynchronous reset. Another difference is based on the design complexity. Synchronous reset requires the use of a flip-flop or other memory element to synchronize the reset signal with the clock signals. This adds some complexity to the circuit design, but it also helps ensure that the reset signal is properly timed and that glitches are avoided. However, in case of asynchronous reset, does not require the use of a flip-flop or other memory element to synchronize the reset signal with the clock signal. However, it requires careful attention to the timing and the potential glitches that can occur due to the lack of synchronization. So overall, it is based on the choice what you should use, synchronized or the asynchronized reset. It also depends on the circuit requirement too. I hope this theory concept is clear to you. Next question is, consider a 4x1 mux if the select lines are A and B. Take the inputs as C, C bar, C bar, C. Then which gate is inferred? So here just consider the table. Two select lines A, B. So 4 possible combinations 0, 0, 0, 1, 1, 0, 1, 1. And you have 4x1 multiplexer. So input is given C, C bar, and C. So according to this table, you can see these two values A and B are same. That time we are getting C. When these two are different, we are getting C bar. If we consider C equals to 1, then it will implement an XNOR gate. Why XNOR gate? Because in case of 0, 0, output is 1. In case of 1, 1, output is 1. In case of 0, 1 and 1, 0, output is 0. So it will implement XNOR gate. But in this question, it will implement other gates too. So in comment section, let me know what gate you are getting. So the next question is, what are the different Verilog elements? So already in our Verilog lectures, we have discussed about the different Verilog elements in detail. You can watch those videos. So basically we have white space, then comments and signal values as different elements. White space means you can use the \b, \t, \n respectively for the blank space, tabs and the new lines. For comments, you have the single line comments and multi-line comment. For single line comment, you need to use the double slash. For multi-line comments, you need to use the /*. You can start with that and you can close with the */. For signal values, you have 0, 1, X and Z. 0 means logic 0, 1 means logic 1. Capital X or small x means unknown state and capital Z or small z means high impedance state. So these are the different Verilog elements we have. Coming to the last question of today's video, what is the difference between RAM and FIFO? So RAM is a general purpose memory that allows random access to data, while FIFO is a specialized type of memory that is used to manage the data flow in system with asynchronous data source and consumers. RAM is used for the temporary storage of data being processed by a system, while FIFO is used for buffering and queuing data between different parts of a system. Talking about the major difference, FIFO stands for first in, first out. It is a type of memory that is used to store a sequence of data elements in order in which they were received. The first element received is the first element that is retrieved. FIFO has two main operations, write and read. FIFO is commonly used to manage the data flow in system, where the data is produced at a different rate than it is consumed, such as the communication protocol or the data processing pipeline. So there we use the FIFO. FIFO is implemented using the buffer of memory with two pointers. However, in case of RAM is a type of memory that allows random access of the data. This means that any piece of data stored in RAM can be accessed directly and quickly without having to read through other data first. RAM can be read from and write to, allowing data to be stored and retrieved as needed. RAM can be organized in different ways, such as a single block or as multi-banks of memory. RAM is commonly used as a temporary storage location for data that is being processed by a computer or other digital system. So these all are the major difference between the RAM and the FIFO. I hope it is clear to you. So guys, this is it. This is about today's video. I hope this video is helpful for you. Do subscribe it guys and like the video. Thanks for watching. We will meet in the next video.